Hello. Say hi in the chats. Got my Twitter notification. I'm on time / early. Early is on time, right? Is that how it goes? Let me just pause my incoming streams. Hello, hello. Hopefully everything is set up okay. Let's check. Oh, you know what? Make this fatter. Like that. Can you all hear and see me? Popping in to say hi from LinkedIn. Hello. Bruce says yes, both. Hello. Perfect. Thank you. Thank you, Charles. All right. Good. Did I forget to do low latency? I don't think I did. I think I remembered everything. YouTube's good. Hi, George from Canada. Hello. I figured out why CatCam was all blown out last time. Turns out OBS has controls for it that are on manual mode by default. Or at least they were. Changed it back to auto. And Spook even came out of his crate to sit in the CatCam for us, which is good. Hello, Hugo. Good and happy time zone, folks. And joyous Friday. Yeah, it's mid-afternoon here. Oh, you know what? I have something to add to the notes. Hi from Buffalo, a literal stone's throw away from Canada. Hi, George from Buffalo, and hello, Juan. Dynamic Sun is from Germania. Hello. Kay Santima from South Dakota. Gary Z from Woodinville. Oh, you're close to me, assuming that's Woodinville, Washington. Hi from Iowa. Richard. Hello. Moto Taimo from Portland, Oregon. Happy Friday. Good morning to Unexpected Maker. Nice. Gary Z, you're in Seattle. We have a hardware happy hour for Seattle. If you're not a part of it, you should check it out. Hello, David, from north of Seattle. Mike Kelly's from Michigan. Where in Michigan are you from? My wife is from Kalamazoo. Hello from Brazil. Jose. Hello, hello. It's live streaming's amazing. So many people from so many places. Hugo, howdy from a Canuck in Texas. Saginaw area. I don't know my Michigan geography that well. Actually, hopefully my relatives aren't watching, but I made this Michigan-shaped ornament. This is the one where I debugged it all. It runs CircuitPython. It's a wet Friday from Portland, from Justin. Adam's from Minnesota. Hello, everybody. Thank you all for joining me. We could even get going on time, I guess. Breton is from Alberta or Colorado, depending on the day. John from Red Hill, UK. Hi, all. Ben says hi as well, who I think is in Germany. Saginaw is on the ornament. Can you tell I just copied it? Yeah. I guess Saginaw is there. I even put a NeoPixel there. Hamburg. Good day to be inside. It's nice and sunny out here. Not rainy yet, although I bet the rain's coming our way. Up from Portland. Okay, folks, it's 2:01. We should get going. And you know what? I think I got the timestamp thing going. So let me just hit the timestamp. Yeah, looks right on time. Let me switch away from CatCam. Hello, everyone. My name is Scott, and I work for Adafruit on CircuitPython. CircuitPython is an open source re-implementation of Python designed to help people learn to program on microcontrollers. Hello, Keith the EE. Adafruit sponsors CircuitPython development. They've been paying me for over 4 years to work on it. So if you want to support me, please support Adafruit by going to adafruit.com, purchasing whatever you see there. There's lots of interesting things. Check out new products. We're always coming out with new things. One of the newer things is the MagTag here that we'll be using today. If we just take a peek at the overhead, and it's frozen, so I'll have to unplug it and plug it back in. But you can still see it. You just couldn't see my hand tapping it. So yeah, the MagTag is one example of products that Adafruit makes. Adafruit makes these inexpensive electronics to get people into making things for themselves. Hello, Gary from Ireland. Mr. Who 30 is from Austria. Hello. So yeah, support Adafruit. If you want to hang out with me and a bunch of other really cool folks, Adafruit does have a Discord server, which you can go to by going to the URL adafru.it/discord. I was telling my neighbor about the company I work for, and I was like spelling out the name of the company, and I almost put the dot in there because I'm so used to it. So yeah, this is a deep dive. This is a stream that I do every Friday, nearly. And it's... Oh, somebody's following me on Twitter. I do this every Friday. It lasts about 2 hours between 2 p.m. Pacific and 4 p.m. Pacific. I usually go by 4 p.m. just a little bit. And it's a chance for me to just show off what we've been working on in CircuitPython, particularly what I've been working on. I tend to work on the very core C code of CircuitPython, so it actually gets pretty detailed pretty quickly. I'm happy to answer questions, but I also usually kind of like show what I've been working on, so I can fill the time if we don't have questions. Yeah, so it's normally Fridays at 2, but occasionally we do shift it. Jesse asks, do you work for Adafruit? Yes, I'm a contractor, freelancer for Adafruit, so I technically have my own LLC. But my only client is Adafruit, and I work remotely. So Adafruit's based in New York City. I'm in Seattle here, but I've been doing that since like August of 2016 when I started working on MicroPython for them. So yeah, if Fridays don't work out, I usually stream on Thursdays at 2 p.m. And I want to say next week will be on Thursday. We're taking a long weekend for our anniversary not this weekend, but next weekend. So we're... I'm not literally CircuitPython. I started CircuitPython. I was the first person for the Adafruit paid to work on it full time. But there are more than just... Like, Adafruit funds multiple people to work full time on CircuitPython, not just myself anymore. So if you like CircuitPython, please support Adafruit. They put a lot of money into the folks that make it possible. And it is what it is because of Adafruit's backing. So yeah, next week is going to be the last stream of the year. I'm not exactly sure what day I want to pick it back up. I mean, it won't be later I think there's like a 3-week gap if I just do Fridays, because the holidays are actually on Fridays, I think. But yeah, next week, Thursday, 2 p.m. Pacific, right after JP. And that will be the last stream of the year. And I'll post on the blog when I know exactly what to do. We're going to kick off CircuitPython 2021 planning on the 1st as well, so I'll at least have a blog post then. But maybe that's what the first topic of the year could be, is like really big vision sorts of stuff that I've talked kind of in and out about off and out in all these streams. The last piece of housekeeping, the cat in the picture is Spook. And I just a heads up that he is epileptic, which means he does have seizures from time to time. He's been doing really well. He hasn't had them recently. but that can always happen. And if that happens, what I'll do is I'll just mute, you won't see him, and then I'll just make sure he's okay and then come back on the stream. So that's the heads up about the cat. Yeah, it's been years that he's been epileptic. Like he actually started having seizures before I joined Adafruit, so it's been like 5 years. And it's actually been going really well. He switched meds like this fall, and it's actually been working really well for him. So this is his life. Don't feel too bad about it. Like, he lays in that window every day. He has a good life. Okay. My plan is pretty simple. Let me take a time code. My plan was pretty simple. I spent most of the week working on pin alarm, which is the ability to wake up from sleep based on like a pin, like high, or whether a pin is high or low externally. So I've been doing that. But I'm going to take a question that we just got in. So let me push that down the road and I'll hit the time code. So what is it about the S2 that allows for sleep? Is there anything blocking the M4 or the M0 feathers? Asks Moto Time in the Discord. So the reason that we're starting with S2 is actually because of the MagTag. And actually, let me just... Let me show you on the overhead again. And I have to unplug it, plug it back in. Hopefully this won't mess up all the cameras. But I've had good luck with just unplugging and plugging it back in. Okay, now you can see it. Paul says, oh, good cat cam exposure. Yeah, thank you. Welcome. Yeah, I was actually on time. I started getting all the cameras set up like a half hour before, which worked out. So the question was, why are we starting with the S2 for sleep? And the reason really is that we wanted to do this product. It's this e-ink screen. So e-ink is really great because e-ink is really great because it doesn't take any power to show something on the display. And the S2 is really pretty neat because it's inexpensive and it's Wi-Fi and it's native USB, which is like the holy trinity or something for CircuitPython boards. And the idea was really like you would put magnets on the back of this and you would put it on a fridge. And so sleep was really motivated by kind of fulfilling what we wanted this project to be, or what this product to be and the projects around it. So the refrigerator icon here is where you actually put a battery. And so, yeah, this is the thing that's driving sleep. Is there anything blocking the M4 or the M0 feathers? No, there's not. And in fact, a lot of this work where we've talked previously about like what the sleep APIs will be, like all of that work in main.c, which I should show as well, because I think did I show it last week? But basically, like changing the flow of how CircuitPython code is executed, like all of that top level work applies across boards. Like we were very, very conscious of the impacts of those API designs. So like, even though we haven't implemented the SAMD stuff, for example, like I read through the data sheets, I have an idea of how sleep works on those two boards. And so even though all of our work has been focused on the S2, like the adding sleep to other ports in the future should be much more straightforward, because we've done all of the API and the workflow level stuff already. And that work is shared. So really there's like, it's going to be good. It's going to be good. I think there is a debate about like what the next one we do is, what platform it is. But yeah. So there's a couple comments about how, the MagTag currently pulls 250 microamps in sleep. So don't be shocked if the battery dies fast with it still. Yeah. It's not spectacular. This is like one of the first forays for Adafruit into low power design. So I think what you're going to see is that like as Lamore, who designs these boards, learns the details about like picking a better regulator, and like there's this thing with the MagTag where like pin interrupts, you can do any number of pins that go high, but like getting a bunch of pins detected independently that go low is actually kind of hard, or like impossible. And we could talk about that more. So there's like, this is kind of the first thing, and it's going to get better over time. So yeah, this is just the start of us thinking about lower power in the Adafruit product line. I have heard mention a bit about I think we may not do the SAMDs. The SAMD21 on its own is actually not that, doesn't take that much power. I think the thing that we were thinking about that maybe we would do next is NRF, because NRF is really interesting because it's like BLE, it's wireless as well. So let me take another. Actually, let me copy and paste these in. I'm like pretty happy that I at least got the time codes here. I'm going to try to, like, time codes are really useful, so I'm going to try. So DCD says, and I see the questions, which is awesome. DCD says, for lowest power, can we reduce the current draw with the power LED and software, or is it surgery with a soldering iron? I think at this point it's surgery. I would probably just hot air part of it off. But there's no power control from the software for the power LED yet. And this is something we talked about, and Lamore was like, we have to have a power LED that works by default. Like, there's so many problems that you have just like with a product that doesn't just show that it's on. Like, it's kind of like that fundamental thing. So I think we'll see like over time how we handle that. And Hugo's pointing out the link product 4800. So I'll show the desktop off here. So this is it. We don't do back orders, but if you want to find out when things come in stock, check that out. And a top secret thing is also that sometimes there can be a delay between when the emails go out and when it goes back in stock. This is mostly used for us who work for Adafruit to actually be able to buy things before the notifications go out. So if you're really wanting to see it, the way to kind of like usually sniff and see when those things happen is you can go on the Discord and like lurk in the CircuitPython channel, and you might actually see that like we would ping some people that we want to make sure that get them. The MagTag itself is like pretty like most of the way through the like product life cycle in terms of developing things. So it's just going to become more and more available, which I have to tell myself about the new AMD CPU as well, which is what I want to do. Moto Time says that is awesome news. Thank you, Tanning. I might contribute to the M0 then. It fits well with a couple projects ideas I have. Yeah, please do. I looked at the SAMD21 and it doesn't look that hard because there's not a lot of power states on the SAMD21 actually. It's like relatively simple to get it down pretty far, I think. So yeah, take a look at that. Okay, what did I miss? Hugo says, hello, Pavre6. Jesse says it's amazing that it's only $35. Hello, Emmett. Yeah, so $35, like that's partly because of the SAMD, or not the SAMD. The ESP32-S2 is really well priced. Benjamin asks, do you know when it'll be available again? And I don't. I mean, that like I'm not anywhere near the production, so I'm not. I don't see that. I know that they're like in the final stages of building stuff for the holidays, so I imagine that they'll. And on Ask an Engineer, Lamore also mentioned that they were like out of connectors. Like I don't know what connector it was, but they were like waiting for a connector that they needed it. Oh yeah, that's what Tim says too. It was a delay in the JST connectors. So Breton asks, and let me copy this into the doc too. Even though I think I might have answered it already. I'm just trying to be good. Where do you think the NRF52840 boards will be in the pipeline for sleep functionality? I actually kind of expect that they'll be sooner rather than later. I actually want to circle back to the NRF52840, or the NRF in particular, because I got some microbit V2s. And I'm starting to think more and more, and this is kind of like pre-brainstorming for like CircuitPython in 2021. If you don't know what I'm talking about, let me just show it. Oh, nice. Paul says, distracting me. Listening to you from Lisbon, Portugal. Amazing. You are definitely my youngest follower at 74. Today was the first successful upload of CircuitPy bootloader onto Kaluga. Awesome, congrats. Okay, so I should talk about this because I want to preview it. We can even kind of see how good my predictions were. And let me add a time code. So a lot of the way that we run the community of CircuitPython is actually based on Rust. The Rust community is really well run. And so as we chose to not be MicroPython, but be CircuitPython, code of conduct and things like that, like I looked a lot at the Rust community and how they did things. And one thing that they do is they do this kind of like call for people to blog what they think CircuitPython or Rust in the next year should be. And I really, really like that idea. It's evolved a little bit how we do it. But here you can see this is the recap from 2020. And it's just a list of all of a lot of different folks involved in CircuitPython and kind of like longer term how you feel the project's been doing and what you would like to see the project do kind of in the coming year. So we'll do this in January. But if you're new to CircuitPython, which I think a lot of people are because of the S2, like this can be really interesting to look at. And I actually just want to pull mine up and see how we got. Let's just pull up mine. So my focus for 2020. Oh yeah, we'll have to get a new graphic as well. Paul got caught up by 2xing, and now my voice is yeah. Breton says the microvit V2 are NRF52833 in the same family as the 840 but cheaper. The 833 boards coming in the future might end up more accessible because of that. Yeah, the thing is that the microbit V2 does not have yeah, this is what I want. This is why I wanted to bring this up. Some community stuff, and this access thing. So this is something I've had on my like year-long plan for a while, is this idea of being able to do code editing over Bluetooth, specifically BLE, not classic Bluetooth. And you can even see that that's like my second of 2 points. But this is the microbit V2 just came out. It's got more RAM and more flash, so we could actually run CircuitPython. But the problem is that even though the chip has native USB, it's not broken out on the board, which is like a huge want. Really disappointing because like we've been so USB focused. But I really, really do want to do this like BLE workflow as well. And so I kind of expect to kind of circle around to the NRF again, especially as the S2 becomes stable. And I think what I would like to do is actually like properly have like a BLE only version of CircuitPython, which could be really interesting because it actually does open us up to a lot of boards. It opens us up to, oh, you want me to scooch it over? Yeah, I made it bigger for another There you go. Thanks for the heads up, DCD. It's like a little bit too far over, but that's okay. Yeah, so this BLE workflow stuff is, I've conflated it a lot with this idea of glider. And I think what I need to force myself to do is like circle back to the NRF, do just the CircuitPython side of like loading files and getting the REPL access, and then like building really basic, very bad apps on top of that on the iOS side. Because once I do that, once we have a proof of concept, people can make better apps for it. So I would like to get back to the BLE only workflow, both for the microbit v2, but it potentially also opens up a possibility for the ESP32-C3 that was leaked and then announced. And somebody pinged me earlier today that somebody who works at Espressif was like, email me if you want a dev board for the C3. So the C3, if folks don't know, is it's a new chip from Espressif that does not have an extensor core. It has a RISC-V core, and it's meant as a replacement for the ESP32-66. It does not have native USB. It has a native USB to serial converter in the chip, which is weird, but it's meant to be really, really low cost. But it does Wi-Fi and BLE. So if we had like this very structured workflow for like, this is what CircuitPython BLE only means, then we would be able to like branch out into things like that. And in fact, we could also do probably the ESP32 as well, which people really would love to see as well. So that's kind of one thing I'm thinking about. Yeah, skateboard baby steps. Be agile about it. I over-engineer by default. Yeah, I do too. Sometimes I want to do all of the things at once, and I need to be better about doing that. Bruce says, "Lol, you answered my next question about the ESP32." Jesse says, "CircuitPython supporting BLE with no USB sounds like an awesome idea. So many people aren't using CircuitPython since they want ESP32." Yeah. Yeah, I think so. I think, I mean, the IDF has a pretty good coverage for all their chips. So I imagine that like, if we do the NRF workflow thing, if we do BLE workflow with the NRF and kind of figure it all out in the same way that we've kind of figured out all of the sleep APIs we want, we'll do it on NRF first, and then we can get microbit v2. And then after that, like the S3 and the C3 will probably be available because the ESP32-S3 is also kind of in the works and coming. And like we're going to want regular Bluetooth support for that. And so if we build the BLE workflow stuff on top of the BLE APIs we have internally, like it should just kind of work across. Jesse asks, what's the S3? The S3 is also, I think it's been leaked. S3. It's like a slightly more powerful, it's a slightly more powerful ESP32-S chip that also has BLE in it. And it's, yeah. I've heard some things about it. I don't know how much has been leaked. But yeah, it's well known that the S3 is coming and it adds BLE. It will also still have the native USB too. Okay, Pavre has a good question that will pivot my rambling probably. So let me take a time code first. The GitHub for Espressif leaks a lot. Yeah, you're totally right. It does. You can find things. Okay, so Unexpected Maker says S3 is again dual core, Bluetooth 5, Wi-Fi, back to 520K SRAM plus some new goodies. George says, is the current bootloader for the Kaluga available? I'd be up for helping get it ready to be released. check the tiny UF2 check the tiny UF2 repo. I think it is. I think it should work. Okay, I was going to answer Pavre6's question, or at least try to, after I take a time code. So, Pavre6 says, when is it a good idea to use BLE over Wi-Fi? And I think that it comes down to what you're trying to do. If you're trying to read something from a website or things like that, I think if you're doing internet stuff, like Wi-Fi is the easier way to go because you can go directly to the router in your house. The problem is that Wi-Fi takes more power than BLE. So with Wi-Fi, you get simplicity, and thanks to Espressif, largely you're not paying a premium for Wi-Fi, but it's extra power, and if you're going there, that's good. Yeah, Mr. Who 30 says range and packets transmitted. Yeah, that's good too. Like BLE is Bluetooth low energy, and so it's going to be a lot less power hungry than Wi-Fi is. But you're just not going to get as much data through. So I like BLE. If you see on Learn, like I have this project that John Park wrote up, but I did the code for, called the Broadcast Net. And I really like this idea of, like, I have a Raspberry Pi behind me that's just like scanning BLE all the time. And it's scanning BLE all the time, and it's listening for these like sensor readings that I have on just independent boards around the house, and then it logs those to the web. So I think BLE is really good if you're doing low power, low data rate stuff. The other thing I guess I should say is that I think BLE is a better experience if you want to do workflow things. So if you want like for a CircuitPython device to interface with an iOS device or an Android device, like the better way to do that is over BLE as well. I find like doing stuff over Wi-Fi, like network discovery stuff, just never works that well for me. So I would like to see BLE from the like workflow perspective. Hope that answers it. There's much more advanced discussion in the YouTube chat. Paul asks let me take another type code. This is a super common question, so I should just cover it again. The CircuitPy disk I now have in the Kaluga has approximately 1 megabyte of space. Can that be increased? Not easily. I just answered this for somebody else this week. The reason it is that much, and I can show you where it's defined. So you can change it if you wanted to. It is kind of like defined in one location, so it's not too hard to change. But I'll tell you the reason that we went with what we do. So if you go into ESP IDF config, and then partitions. So this is the layout of that 4 megabyte flash that's on the Kaluga. So the first 64K is like a bunch of small things, like the stage 2 bootloader, the partition table, which is like the binary version of this file. NVS is like non-volatile storage that's just like for a little bit of stuff. And then OTA data is keeping track of which one you're using. And this is the crux of why it's the user file system is actually only 960K. The reason is that we have 2 spots for CircuitPython to live. Ooh, Ivan's in the chat. Huge shout out to Ivan for helping me earlier. Thank you so much for helping me with some light sleep stuff. Ivan works for Espressif, and so has been a huge help. Yeah, so the reason that we only have 1 megabyte user flash is because the binaries are really big. So you can see that we have 1400K just for each CircuitPython version, and then we have two of those. And we have two of those so that we can do over-the-air updates, which is going to be really neat. It allows you to like download a new version of CircuitPython or whatever, write it to the flash, and then restart and run the other code. And then this factory partition here, that's 256K, is the space for tiny UF2. So this is where the UF2 bootloader goes. And that's a good segue. Let me show off and shout out MicroDev. Jesse says, we need a config to remove the OTA partition, I think. You're welcome to do it yourself, but like for CircuitPython proper, we don't, like, I'd rather just like stick to one. It's hard to support different things. Yeah, so MicroDev's been a huge help with all of this Espresso stuff and has this pending PR that adds OTA support, which is really neat. So it's in progress. It's a draft, but it's talking about what the it's doing this shared bindings work to figure out like what the module looks like. And it's basically you flash something to the flash and then we'll switch to it after we restart. So yeah, that's very exciting. MicroDev's done a really good job of like adding like all of the CircuitPython APIs to the Espresso stuff. So huge props to MicroDev for that. Okay, lots of excited folks. Ooh, Ivan says 802.11ax supposedly addresses power consumption and Easy Connect should improve onboarding with smartphones. So hopefully, I mean, things always get better. I'm a firm believer in things just getting better over time. It just takes time. The majority of Wi-Fi AP have Wi-Fi 6 out this month, and RLL chips should be shipping next year. RTL chips. 6E is what is intended for lower power. All right, I think I'm caught up. The other thing I should shout out before we get into the pin alarm stuff that Ivan was helping me with is, and I have work to do there. I actually want to finish the PR today. So that's what the majority of this deep dive will be. Again, if you have questions, I'm happy to answer them. But I also wanted to... Oh, and I meant to caveat talking about what I want to do, like all the low power stuff. It always comes with this giant asterisk because we don't always know the new chips that are going to come out. So if new chips come out and they're really interesting, like we may reprioritize things. And the S2 is like an example. Like if you looked at our development like throughout this year, like once the S2 was available and we got our hands on it, like we kind of like dropped all of the other stuff we were doing. So like there's always this asterisk of like something new could come out and be really cool, and kind of like switch our plans. Oh, the other thing I wanted to shout out was the work Dan did this week. Since we're talking about sleep, Tabletronics has S2 PCBs on the way. You're excited. Awesome. I hope he adds a board definition to CircuitPython for it. I think we're actually like one of the better, like more mature platforms for the S2 right now. If you ignore the IDF, like the IDF is like what we're building on. So if you just did that, like you'd be good. But I think from what I've heard, Arduino's pretty rough still. So we're trying to get over that hump of all the bugs that we're seeing too. Benny's fixing this UART thing. Dan's adding sleep memory. So what this is it's an API so that you can write to RAM. So it's like non-volatile in the sense that it will be preserved across deep sleeps. But it's not so non-volatile that it won't be preserved over power loss. So it's like somewhere between writing to Flash, which we already have an NVM module for, and like the stuff that you have in your like CircuitPython heap. So Dan is adding sleep memory. And so this is just an alarm.sleep memory. It acts like a byte array, and then you can write to it, and that will be preserved across resets and across sleep as well. Unexpected Mirror asks, I've been absent from the CPI issues list in Discord chat. Any progress with the I2C and Wi-Fi issues? Yeah, Bruce fixed it. So thank you, Bruce. It was something caused around, I think, like trying to completely de-init all of the I2C stuff, which is probably an IDF bug, but yeah, I merged Bruce's fixes to that, and because like you never really know if something's fixed until you get people trying it, and so like merge it, try it, like it's not a stable release, so yeah, thank you to Bruce for that. Thank you. We've had so many new folks coming in and helping with the S2 that like it's really, really appreciated. So thank you all, and welcome. I hope you stay. CircuitPython's just getting better and better, I think. Okay, so if you're doing sleep stuff, check out Dan's PR for things. Bruce had fun finding the I2C Wi-Fi thing. That was a wicked bug. Like it burns Jeff out. Jeff took a break and did some guides from CircuitPython core work. Just like those sorts of bugs are the worst. Okay. I think it's time for me to start diving here. Let's see. I talked about that. Oh, before I start diving, and Bruce pointed, I think it was Bruce pointed this out on the Discord already, but I had some people really appreciate the mention I had for the power profile kit. And I ordered it, but it was back ordered, and mine was shipped out today. So I think it is actually available. Yes, 130 in stock. So if you saw it last week and wanted it, but if you didn't realize it's back in stock, it's back in stock. So celebrate PPK 2 is back in stock. I think I'm gonna switch to it once mine comes. I'm actually it has the ability to have 8 digital inputs. And if you didn't know, like DigiKey is a huge partner of Adafruit. So if you support DigiKey, you're also supporting Adafruit. Mike Causer asks, where did the name MagTag come from? I don't know exactly how they come up with it, but it's usually like most of let me take a time code. I just thought I could talk about all these sorts of things, which is really what my stream is all about. Hope you're all okay with that. So the question is, where did the name MagTag come from? And if you've followed Adafruit before, I think Adafruit always has cute names for things, and calling them cute names is maybe not fair, but like they have their own names for things, right? They have their own way of branding things, and I think that's deliberate. One is because branding and trademarking is super important, especially in open source world, because your value comes from that identity of your brand and what it entails. So so like branding's really, really important. It has one function in that it like associates the products, like the products that Adafruit makes with Adafruit, and differentiates them from products that other people make that may be similar. So that's like hugely important. And then there's also this importance of like, you can kind of understand how people learn about things by the words that they say. So like whether somebody refers to WS2812s or things like that as neopixels or not is like you can kind of like get a read on that. So the way that it works is like Phil's, so the Adafruit is owned by Lamore, Lady Ada, and the number 2 person into the company and the number 2 person in running the company is Phil. And Phil's background is in marketing. And so he manages the company day to day. And it's a process of like him brainstorming along with Lamore where you get all of these names. So I don't know exactly like what their thought process was for it. Certainly there's this part of like, not only what is the name, but like what iconography would I use with it? Like I showed the refrigerator on the back of the MagTag already. So like they have a designer, Bruce, who does all of the graphics design that you've seen. And like that'll influence like what name they go with as well. The MagTag and Mag stands for magnetic. I think the tag comes from like also being like the e-ink is commonly used in like price tags in grocery stores. Yeah, so I think the principle around it is like, yeah, fridge magnet. Exactly. Just like Keith EE says. So yeah, it's a process usually involving like they ask all of us to like come up with names and brainstorm, but it's usually like Phil and Lamore were walking around New York City and brainstorming. Like their life is Adafruit and a lot comes from them. Like people don't give them enough credit for what Adafruit is. Yeah. Adafruit's an awesome company. Okay, I should get to my real work in just a sec, but Bruce asks one minor question. Let me take a time code again. All my chats are dark mode. So my docs are wrong. One minor question. I noticed that the I2C code uses the Freertos static semaphore in a way that works but isn't really documented. Using the static buffer as the semaphore handle. The API doesn't document that. I found random notes somewhere. Yeah, I mean, I don't know what your question is. It's probably just an artifact of me not understanding Freertos very well. I think I did do that code. But yeah, I do tend to like dig into the source and then I may use it some way that's not documented very well. Generally, I try to not, I try not to use Freertos level allocations if I can, which is why I, like, if you're seeing, like, me pass in memory instead, like, I much prefer to do that. Bruce says, I think the last conference I was at had BLE/NFC tags. Yeah, we've done like PyBadge and Edge Badge, which is what PyBadge evolved into. This is our like second or third iteration on e-ink stuff since I've been at Adafruit. Okay, let's talk pin alarm. I can obviously, if you have more questions, I'm happy to answer them. But so what I've been working on is pin alarm, which is having the ability to, so we were working on sleep last week. Last week I was doing like tweaking how the sleep worked, but like not adding any kind of new functionality to sleep. So, oh, George says, since FreeRTOS has a good task structure and Embed has something similar for ARM, is CircuitPython ever going to add support for tasks? If somebody added it, I would take it. I was talking with somebody. I was talking to Jay Carlson because I was pushing him to try CircuitPython. And he asked, like, why wouldn't you do threading? And like, there's this balance of like, I don't think it's important to add threading, but if somebody added threading, then I would be like, cool, like that's fine. Like it's fine for if somebody wants to add advanced things to CircuitPython, but like that's not where I see the benefit for Adafruit and therefore myself, and also what I'm interested in. So if somebody wants to add tasks or like threading, like you're welcome to it. But that's not my plan. Like, I think concurrency is really complicated, and I just I don't like it. I like the simplicity of having one thing running. And my focus is on like onboarding beginners. So like I want CircuitPython to be good for people who are learning to program, and I don't think threading or concurrency is like something that makes it any easier for beginners. um, yeah, I mean, MicroPython has threads, and that's also another thing is like, oh, this is great. We have lots of good questions. We do have, Johnny says threading is complicated. One solution is to add async calls. So this is a perfect example. So Warrior of Wire added tweaked and enabled async IO in CircuitPython. So you can actually do async and await in CircuitPython already. It's just like, it hasn't been propagated everywhere into like async APIs for everything, which is going to be really interesting. But I'm just going to delete this Pin1 thing because I didn't do it. We're not there yet. We've got lots more good questions. But yeah, check out Warrior of Wire's work if you want to do async stuff. Like, I'm not against it. It's just not a priority for me to work on. And I promise you, this is a promise that I've tried to make, is that I will always do reviews on pull requests. So even if I'm saying like I am not going to work on that, if you do the work or if you need guidance on how to do the work, like I am happy to help you do that. I just am not going to do it myself. And that's a fine line and whatever. But like I want to enable other people to work on CircuitPython, and I will put that time towards that. But I would much rather spend my own time doing like BLE workflow, which I think is like, how many beginners can we get coding if all they need is their cell phone and a circuit playground or something, right? Like that is way more interesting to me than getting threading. And MicroPython, like I was about to say, like their focus is more on industrial customers and advanced stuff. So that is an option as well. Like they kind of cover that too. Okay. I have two more questions. Keith the EE says, what happened what happened with the space requirements for those error statements? I got distracted and missed updates over the past 2 weeks. So yeah, we were out of space in the German build of Metro M0, I think, and we were having a lot of trouble with that. There was a couple things that happened. One, I pushed back on Jeff because he was adding a new parameter to e-ink display. It said like, hey, like you need to find some room. And he actually did. He found like a few hundred bytes, which is amazing. So Jeff really took it and did awesome work. Jeff is paid half-time by Adafruit, which is where he wants to be. So like, that's another reason to buy from Adafruit, is like Jeff's work is funded by Adafruit. And then the other person who's paid full-time like me, and there's other people that paid her well, but Dan Halbert is also paid by Adafruit to work on CircuitPython. Dan turned off complex integer support in the M0 builds, and that also got more space back. So we didn't find any examples that use that code. We don't know of anybody who uses it. So that's like the perfect candidate for like, we're just going to turn this thing off, and we don't think people will notice. So all the complex integer stuff on the SAMD21 is now gone. So yeah, that's the update, is that we've got some space back, which is good. Bruce says complex integers get stabbed in the back. Indeed. Okay, there's some chat about threading, so let me respond to that, and then I'll get to Pavre6's next question. I like questions. I would like to get this PR out, though, too. Johnny says, threading is complicated. One solution is to add async calls. Oh, yeah, we talked about that. Multi-threading is really easy as long as you use a value of 1 for multi. Right. Bruce says, I actually never liked it. Always get confused with C#. Jesse said, so right, Scott, about beginners. Embedded systems is the future because the smart home devices need more people working on it and learning it. Yeah, we need generally more people coding. George says, I may take it on. I know Freertos and embed really well. Awesome. I just think real tasks are an important thing. Yeah, please do. I'm happy to give you pointers on how to do that. Probably looking at MicroPython's implementation is the place to start and see how they do it. But I mean, the nice thing about threading is that like you just import thread. So like it's very well sectioned off. So we can have it enabled, or like we are very good at explaining what features are there based on modules. So having some builds that have thread would be totally fine. Yeah, and Mike says, worst case, it's a feature flag, so people who need it can enable it. I don't think so. I mean, I think if we have the room, like on these new platforms, like we generally have the space for it. It's just like, I don't want it to impede that like low, like making it really easy, hopefully. Mr. Who says, so the Sandy 21 is more end of life. Yeah, I think in terms of CircuitPython, we're not adding much to the Sandy 21 simply because we don't have the room. So like as we add new modules, most of them probably won't be backported. But we'll continue to support it, obviously. It's just like 32K of RAM is like quite tight. And it's not really like people don't really have like a great experience with it anymore. It's pretty limited. It's always been limited, but it's as we write more libraries and the libraries build on each other and they're tested on CPython and the Raspberry Pi, they may not be like super small memory footprint sorts of things. So yeah, generally like go for the SAMD51 or the NRF52840 or the S2. It's going to be a better experience. I'm actually like, one thing I want to do is I would love to see us retire the M0 products. So like not sell any more of them. I think that, yeah, I'd love to find an alternative. And I've talked about this on the stream before. I've got my eye on the STM32G4 series. They have their Cortex M4 devices, and they have ones coming out next quarter at the start of next year. That is a 32 QFN, which is like the size I think we would need for like the Trinket and the Cutie Pie. Yeah, so I'm always looking at new products that are coming out and wondering like and figuring out how they can fit into like the Adafruit product line. And BGA is another thing. Like we could start looking at BGA boards as well. Let's see. Ryan G says it would be interesting to see multi-core support for the Propeller 2. I think that multi-core support is really interesting, and it's something that I've just started to think about. Let me take it. I think I'm on here still. So, as you know, I've thought about doing bare metal on the Raspberry Pi like 4, and that would be like run CircuitPython on one Cortex A and then have 3 Cortex A's just sitting around. So I think that's really potentially interesting about like, yeah, you could just do multiple threads or multiple tasks. but like, what if you don't? And then the S2 also has multiple cores, right? Like it has the ultra low power processor. So it has the ESP32-S2 has a RISC-V core in it. And so like what sort of APIs would we have that potentially, like, especially the ULP, like you're not going to run CircuitPython on it, really. I mean, it's 8 megahertz, it'd be fine, you could do it. But like really what you want is like, here, load this tiny bit of code and just run it separately. Hugo says, what if you had 4 CircuitPython environments on the RPi, 1 per core? You totally could. Yeah, I think it's interesting. I think it's gonna be an interesting world of experimentation. Of like, personally for me, I kind of like the low level stuff, so I'm like kind of interested in like, if I have a RISC-V core, writing RISC-V assembly and just loading like on the ULP. What if I could run like 20 lines of RISC-V assembly that I have like a Python library that takes that RISC-V assembly, spits out the bytes that are that, and then just loads that into the memory and runs it. Like, I mean, part of me kind of likes that idea. I like that idea of, yeah. Thanks, Paul. Have a good night. Mr. Who says, without any core/memory management. Yeah, I think it's interesting. I think, you know, I've been thinking a lot about, especially with the Raspberry Pi 4 wanting to run on that, like this crossover gap, which is what you see the semi manufacturers doing, is like the IMX RT is one example, and then the STM32 MP1 is kind of from the other end. Is like the semiconductor companies are trying to like fill this gap between like high-end microcontrollers and low-end Linux capable boards. And I kind of feel like with CircuitPython, we can blur that line as well. And I think that like, if you want core and memory management, use Linux, that's fine. Like, but if you want something like lower level bare metal single task sort of thing, like I think that's where CircuitPython excels. And I think CircuitPython could also excel as something that's like, I have CircuitPython on 1 core, and then I have 3 small programs that are like very running intertwined at a low level. And CircuitPython's geared towards managing that. I think that could be really interesting. And Deco says, what did he just say about a processor that can go on the Qt Py? Was it more powerful? Did it have built-in Wi-Fi BLE? The one I was thinking of is more powerful, but not Wi-Fi BLE. But Espressif is doing really interesting things with the S2. I don't know if folks saw this. I subscribed to changes on the ESP32-S2 product category. Again, I'm just like winding my way around stuff. But product. What is the document? Anyways, Espressif has announced that they're creating a chip for the ESP32-S2 that has the flash and the PSRAM in the chip itself, which is very cool for making small things with the S2 on it. It's sunny outside. Yeah, Paul says, in 1978, it was also jiggling with assembly on the Apple II, reusing RAM 64K on the run. Exactly. Swarm Drive says CircuitPython. So for those of you in the chat who are saying CPython, that's not a great way to make it shorter, because CPython is usually the designation used for real Python because it's implemented in C. So either I usually do CircuitPython or just CP. On a Z80 or a 6502 boards would be cool. Anything under 32-bit, you're not going to be, it's going to be really hard. MicroPython, which CircuitPython is built on, plays a lot of tricks with 32 bits. And so like any sort of CPU that doesn't do 32 bits, you're going to have like, it's going to be a ton of work to port. So you really need a 32-bit data path to do it. You also need USB to be proper CircuitPython. Although I was already talking about like maybe we have a BLE only mode. Oh, and then the other thing I should do is lots of good questions. So Professor Sparkles, who's in the chat occasionally, did this really cool design at my request, which is Timon did a Metro-shaped, Arduino Uno-shaped Raspberry Pi 4 carrier board. Hey, microdevs in Discord, say hi to microdev, and thank you. So this is a design that I was suggesting could be cool. It's a carrier board for the Raspberry Pi 4 compute module, shaped like an Arduino Uno / Metro. It was interesting. He's actually trying to get Linux acting like CircuitPython to the degree that he wants it to show up as a USB like drive to other folks. So he's got some, if you're a Linux person and want to help, he's got an issue with it. But it's very cool. So like the board itself has the footprint for it. Yeah, it's very cool. And like I said, it's like very much blurring that line from like the like Linux world into the microcontroller world. Oh, and he even added an ADC there. Nice. CircuitPython on an 808. You know I did the 808 puzzle, right? It's not finished yet, and I need to get back to it. But I have a puzzle. I have a puzzle of the 808. Ryan says, I think you could load a spin to assembly binary under prop core and point it to a stack allocated from CircuitPython. Yeah, I don't know enough about the propeller to know how feasible it is. Oh, that puzzle. It went around Twitter. It's my most popular tweet. I broke 1,000 likes, which I was pretty excited about. All right, Mo. We don't need any more V's in chat. Tim says, embedded Linux is my day job and my hobby. Ooh, Yocto project open embedded. So there's this, I think he put it in the thread here. You should definitely follow him. Oh yeah, and Greg pointed out that the ADC's there. Gregory. Yeah, so definitely follow him. There's somewhere in this thread, I think, there's a link to, and maybe he just might have been a DM. But there's an open issue about like when you're a USB gadget with a mass storage device, like the Linux doesn't find out when the drive, like when the files change, which is what you would need to do, like the CircuitPython style, like reload the file when you write it. Neradoc says, didn't Lady Ada talk about the S2 chip that includes flash the other day, maybe for Cutie Pie? Yeah, I think she did. The chips that she got, I think she has in person are just the built-in flash, but they actually announced a version that's also built-in flash and built-in flash and built-in PSRAM, which is blowing my mind. I'm sure it's just like connected in the package, but that's like such a great idea. Keith E says, bare metal single task is actually a great way to describe why you'd pick CircuitPython versus embedded Linux with Python that I never made the connection to. Thanks for that mental framing. You're welcome. I mean, I'm all about simplicity. And I find single task stuff to be simpler. Yeah. So Tim says, also we know how to build Freertos with Yocto project and open embedded. Nice. Hi, Roberto from Ecuador. Breton says, RAM is one limit, but CPU on a simple MCU that is hand solderable like a TQFP would be useful for making CircuitPython more accessible. STM32 L4, L5, or G4 are a useful alternative. Yeah, I think the G4 is really... I'm really interested in the G4. Like, this is... Like, for this project, I just did a SAMD21. Like, this is kind of as simple... Like, the SAMD1's great. 21 is great because it takes, like, one capacitor. So it's, like, a regulator, a flash. Like, it's a very simple circuit. But yeah, so like that's the answer right now, but I'm like I very much have my eye out for what it'll be in the future. And like the STM32G4 access line, it's even in my history here. Like this is really what I have my eye on. It's just not available yet. And I've tried to like poke Lamore to get her to email them and see if we can get it sooner. But she's been distracted. So yeah, the access line here has these 3 SKUs that are marked with this Q1 2021 box. So they're 32-pin LQFPs and a QFN. And then, but the new ones, like the regular ones have 32K and up to 128K flash, which is just not enough to fit CircuitPython in the flash, and it's going to be like a SAMD21 in terms of like your RAM usage. But they have these new SKUs coming out that are 256K flash, so like SAMD21 amount of flash, but 112K RAM. So that's going to be like way more pleasant to use, but it's still in that like that small pin, low pin count form factor. So I'm really, really excited to see these newer SKUs be available. I keep checking this page, but they're still not. Pimoroni made a pirate Python that boot a tiny Raspberry and a Pi Zero and run Python and memdisk. Not bare metal, but hiding the Linux. But they had a problem in making the file system accessible over USB. Yeah, that was kind of a CircuitPython model, but on Pi hardware. I believe they did that for Cisco and some other education project. Yeah, I think you just need Linux expertise. I think it's doable. Like when I talked with the BeagleBone folks, like years ago, like at least a couple years ago, like Jason Kreidner's reaction was like, why didn't you just use Linux to do that? So yeah, I think it's doable. I don't have the expertise. And I don't imagine a lot of people use the USB gadget system on Linux, which is the system that makes it look like a device. Okay. All right, we're full up of questions. Let me get some work done. Let me take a time code. For reals this time, folks. I need to get some stuff going. You can ask questions still, but let me show you where I'm at on. So what I'm working on is I'm working on light sleep, or not light sleep. I'm working on sleeping until a pin changes. The pin is either high or low. And the reason I'm doing that, it's useful for kind of 2 situations. One is like a button press. So you just like sleep until a button's pressed. Or a lot of sensors have IRQ lines, which is short for interrupt request, which means that like you can have an accelerometer and say interrupt when it's dropped. Like I think like, remember when laptops had spinning hard drives in them? Like one of the features they would have is like, if you drop it, it will like park the read head so it wouldn't like run into your disks. Like the idea, like I want to be woken up when something's falling. Hugo says, how about we just rename this part of the week as Ask a CircuitPython Engineer and just QA about CircuitPython and geek out on hardware? Like, I mean, that's totally fine with me. Yeah, David G says, can we wake on shake? Yes. Yeah. So the idea is that like you have some sensor that's doing some sort of monitoring that you've configured it to do. and then you sleep yourself, and then but there's an IRQ line that like is connected to you or multiple people. So like I think a pretty common way for it to work is that like you have one IRQ line to the microcontroller, and then it's pulled up by default, and then all of the other things will just like assert it. And by asserted, I mean setting it low. So if it's pulled up and then you set it low, like if everybody's only ever setting it low, then you're okay having multiple sensors connected to the same wire. So this is something people have really wanted, and this is like kind of the beginning of like sleep really differentiating itself from time-stop sleep, because it's not just time. Awesome. QZorn says, hello, just in time for my next ESP32 KiCad project. Awesome. KiCad's great. I'm excited for 6.0 to be released. Okay, so this is the code that I was working on. Yeah, Mike says IRQ and int pin's the same. I think so, yeah. IRQ is interrupt to request, and then INT I think is just interrupt. Yes, so this is the new alarm type. This is my change. This is in my branch for the change. And I was having this problem. I had this test program, and maybe I should do the overhead. Let's get it going on the overhead. Let me show you what I'm doing. You know, it doesn't work right now, though. I gotta fix it. Okay, there you can see my overhead, and it's frozen again, which is brilliant. I don't know why it freezes, but it seems to be okay if I just unplug, plug it back in, and then change the setting. So now you can see it. Okay, so I do have it connected to my Joule scope that I showed off last week. So that's still on my desk. And so to actually get it to run, what I need to do is I need to, so I also have, no, not sudo screen. So I have the USB to serial converter still. And then I want to run, I need to source my virtual environment where I installed Joule scope. And then I can start Joule scope up. You can't see it, but the light did change. It was totally a fluke that it worked for show and tell. Okay, so actually let me show. I think I have the code.py. Oh no, you know I don't, because I restarted the computer before. Don't have the code.py. Oh, yeah, I do. I have it cached. It's not actually connected over USB, but I'll show you what it's doing. So this is the new Sleep API. So here, what we have now is we have an alarm class, or not module. Keith says early product live demos are always the most fickle of things. I think it only worked because it was on USB and then I unplugged it, because there's two modes to how sleep works. It doesn't sleep as aggressively when you're on USB because it wants to preserve the USB connection. So I had like that portion working, but I didn't have the like off USB portion working, which is actually what I'm doing right here is I'm doing the off USB version. So alarm is the top level. So any port that has the alarm module should be able to do sleep. Like that's kind of like the way that we'll say like, is it supported or not, is whether it has this alarm module. And then we'll have sub modules. So that's actually a package for pin and time and other types of alarms. So alarm is this notion of like something that can wake you up from sleep. I like that name for that reason. I'm very picky about naming. What is the major benefits of having an NVIC when IRQ is still doing the job? Well, I think an NVIC is the nested vector interrupt controller, right? That's an ARM thing. And that's delegating between different interrupts inside the system on a chip. So inside the microcontroller. The IRQ stuff that I was talking about is more like outside of the microcontroller. How do you handle it? Microdev says, I think I should wait for your sleep tweaks to be merged in before doing UOP alarm. You should definitely look and see how I'm doing this pull request. But the sleep tweaks PR is merged in, so it should be relatively straightforward. Okay, so this is how I have it set up. I'm checking to see if the wake alarm attribute of the module has been set. And then I'm printing it out if it has, otherwise I don't say it. So this will only happen if we're doing a deep sleep. This is how you find out what woke you up from. Unexpected Maker says, maybe you should have called the alarm module kids if the criteria is that it can wake you up from sleep. You can rename it that if you want as a secret. Okay, so I'm turning NeoPixel power on. I'm sleeping for 5 seconds to start, and this is just regular sleep. And the reason that I'm doing that is that we have this check that we want to make. The sleep works differently whether you're on USB or not. And I had a bug where it wasn't working correctly, so I would actually not be able to do USB even if I wanted to because it did sleep too quickly. So I just had the sleep in here to make sure that that bug doesn't get me. And then I'm initializing the NeoPixels, which you can see here are green to 4, and I'm setting them to red. And then I'm setting a time alarm. So time alarms vary a little bit from time.sleep in that they are kind of absolute, but they're absolute to like a set timer. So like you can either do it based on epoch time, which is like 1970, or monotonic time, which is like an arbitrary, like when you started up basically time. So this is saying like, I want you to wake me up at this time, which is now plus 10 seconds. And so we set that time alarm, and then we pass it into this light sleep until alarms. And then when it returns, because it's a light sleep, it doesn't finish what we're doing. It should just return the same exact time alarm object. The reason it returns an object is because you could potentially list like 3 sorts of alarms and it would tell you which one woke you up. Tim says doorbell equals Adafruit delivery equals happy dance. Nice. Okay, so it sleeps with red for 10 seconds and then it sets it to green and it sets a pin alarm, which is D11, which is the rightmost button. It says alarm when the value is false, and pull equals true says yes, pull up, or pull the opposite direction. So it's not the direction, it's whether it should pull or not. And so this is saying, I want to alarm when it's false, and yeah, you need to pull me up otherwise. And then I print out something, and then I say light sleep until alarms. And then this is a check just to make sure that like if it doesn't work right, infinite loop. And then, yeah, print it out, sleep for a second, and then do a deep sleep. So I think if I hit the button, the green should go away. So the green will stay. So the green is set here, and then I don't change anything else. But deep sleep will not preserve the state of pins, except for the pins that you are pin alarming on. So we should hit green, and then we'll deep sleep. And in fact, if we're looking at the Joule scope, we can see that we're hovering about 5.5 milliamps right now. So that is light sleep, and that is light sleep with 4 NeoPixels on. So like that's pretty good, I think, for a light sleep. But I'm going to hit the button and we'll see if it works. So it woke up, and now we're in the 40s of milliamps. and then it crashed. I think we saw the screen flicker. It's because I'm trying to read the .pin attribute, and I think Dan fixed this bug, but I haven't updated to that fix yet. So my code crashed, and this is an iteration I want to do later as well, of like, what should we do when your code crashes? Like, we probably shouldn't have 44 milliamps of spinning, waiting for who knows what to happen. Like, we could do better things here. We had a question. Love the Factory asks, how much effort is it to get any old modern STM chip, like say the STM32G0 with integrated caps and prototype for friendly footprints, working with CircuitPython? This is a good example. Let's go over it. And in fact, let me just dump a time code. This is a general, like, how do I evaluate putting CircuitPython on something? On new chips. Yeah, David G says, wait, what is light sleep versus deep sleep and wake up at the beginning? So light sleep, you preserve the state of the CPU and the RAM. So you pick up where you left off. But it's not as low power as if you deep sleep. And Unexpected Maker asks, so you're using pin D11, not sure what that is mapped to on the MagTag. It's mapped to this right button, but the pin has to be on RTC GPIO right. It only has to be on RTC GPIO to do deep sleep. Light sleep can do, and it uses the GPIO peripheral, so it can happen on any pin, I think. Based on the docs, I haven't tested it. Okay, so CircuitPython, how do you decide whether it's feasible to put CircuitPython on something? So I don't know the STM32G0 series off the top of my head. So let's just take a look at it. The two main things are you need at least 256K flash, and you at least need 32K RAM to even like have an okay experience with CircuitPython. So those are the first two things. And so these are Cortex M0 Pluses, which are not the fastest thing in the world, but they're like what is in the SAMD21. And then if we look here, we could see flash is up to 512, which is great, and SRAM is up to 128. Now, the other thing that we want is we also want native USB, which we can see here's a USB dev/host 2.0 FS. So it's not in the value line, it's only in the access line. And the reason that we want that is we want that so that you can do like a CircuitPy drive and the serial terminal. There is like MicroPython can only work over UART, but really, in my opinion, it's not worth it. Like, you should always have native USB, although I've been thinking about the world where you don't, but you have BLE. Paul flashed the bin to the Kaluga. How I now can proceed with CircuitPython or MicroPython, and then you link for more info. Right. So the Kaluga doesn't have a native USB port. You have to plug into the individual pins. Okay, so now let's look at the STM32G0 line. And I love these charts. These charts are great. So we need at least 256K flash and 32K RAM. Like, you could probably fit in the 128K, but I'm not positive about that, and you're probably not going to be able to fit very many modules. So you're going to end up in this gray box here, which is actually similar to the G4. So these are available in the second half of 2020. So maybe they are actually available now. And they're 256K flash and 144K. That's actually really interesting. And look here, it's actually 32-pin QFP or QFN. Are these available? Like, we could replace the SAMD21 with this as well. It's not going to be as fast as like the G4, which... So the main difference between an M0 and an M4 is that, hi Mohan, the M4 usually has floating point hardware, which makes all of your math faster. But let's just see on DigiKey, STM32G0. I might add this to my carts. That is really STM32G0. And let's look at eval boards. It's for USB power delivery, which is probably not what we want. It's a G071KB, which might be, there's an EB and GB. Oh, here it is. So, yeah. That didn't really answer your question, but it does interest me. And in fact, I wonder if we could see, like, they're still gray even though they're the second half of 2020, so they may not actually be out yet. But our STM32 port is actually quite strong. A couple places to look. One prerequisite is tiny USB. So like if tiny USB has support, like it does a lot of the work already. So if you just look in hardware BSP, you can see all of the boards that it's kind of like been tested on. And you can see here we have F007, F103, 207, like a bunch of Nucleos, L4, a couple L4s, an L0. No G's yet, but I suspect that they're using the same USB peripheral that they use in all their chips, so it probably isn't too bad. So yeah, those top end top end of the G0s look kind of interesting too. I would probably actually go with the G4 just because they'll be faster. Although, what is the clock speed of these? I can't click them because they're not available yet. Thank you, Bruce. Let's just take a look at. Yeah, let's take a peek at Cortex M0 Plus operating at 64 megahertz. So the SAMD21 is 48, so it will go faster than that. But the G4 is like 170 megahertz, and it's a Cortex M4. This one will probably be cheaper. But yeah, I don't know. M4s are a sweet spot, I think. CircuitPython channel on Discord is the place to go if you want help doing support work. We'd love to see all of the microcontrollers supported that we can. It's just a question of what is a priority for us to work on. Okay, so this has a bug. I was talking with Ivan earlier, and I filed this issue last night. Yeah, so I filed this issue last night. I was having this problem where I wasn't able to light sleep successfully when I was setting a pin to wake up. It was returning immediately instead of waiting for me to press the pin, which is unfortunate. So I filed this issue, and then I have, like, Ivan's nice enough for me to let him private message him and say, like, hey, can you take a look at this? So he got back to me when I woke up this morning, and we debugged this, and so I laid it out. I showed the example, and if we refresh, we can see that, like, Ivan confirmed that it's already been fixed. So there's this bug here. It wasn't actually fixed on, or no, it was fixed on master, but not a version of master that we were using. And it was fixed on the release branch for ESP32-S2 4.2, which was actually just released 5 days ago. And what I decided is that, like, we're really trying to we're really trying to stabilize the S2 work. And we were on like a version of master of the IDF from September. And what I decided once we realized that like the release branch for the 4.2 also had that fix already in, what I kind of decided is that I would rather us track a release branch than track master as a way for us to stabilize. So where I'm at right now in this code is I'm basically moving us backwards in time in the IDF, so that we'll now be tracking the 4.2 release branch. The master is getting all these changes for the S3 and the C3 right now, and so a lot is changing. And so I'm trying to get us kind of away from that churn because we're trying to stabilize. So I think what we'll do going forwards is like we'll follow stable ESP IDF releases. Maybe beta, but like we'll try to like follow their release branches. So yeah, that's where I'm at. If we look here, this is some of the APIs changed. So I'm trying to run down fixing them, which is kind of unfortunate, but it gets me the light sleep fix. That's why I'm doing it now. And it means that we'll be on this like stable IDF instead, rather than in some random master thing that we don't know. So if we find problems that need to be fixed in the future, what we'll be able to say is like, hey, can you merge the fix into 4.2 as well? So yeah, I got to fix these bugs as I switch us back. And hopefully it'll work, but now's a good time to do it because with 6.1, like we're not so close to being stable that we can't accept the churn. And I'd much rather stabilize us on this like fixed, like known good version where we could say like, we're tracking 4.2 release branch. Okay, so I got to figure out what happened to these functions. I've already had to change some of the like include path stuff. But yeah, this is what deep dives are all about, is figuring out how I figure out this stuff. So I'm just going to do spy ll tx dma, and we don't have disable, which is weird. Oh yeah, thanks Bad Abby for linking that gist. If you're getting into CircuitPython on ESP dev boards, there's a really good GitHub gist that I'll post in the YouTube chat as well. It's a bit old, but it's still good. Okay, so it's in spyll txdma disable. I wonder if they added it later. See, that could be an outcome of this as well, as like we might actually need to be like, oh yeah, there's this thing that we need to add back. What I found so far is that like it was just renamed. The functionality was still there. It was just renamed something. It was named something else. So what I'm going to do is I'm going to find components. I'm going to find where it exists now, and then I'm going to see when it was added. Sock source. So this is the old version. But it's probably, let's just see if it's in here. Include spy. This is not the LL. This is the old version. Let's look at the context as well. So it's in common hell bus AO. Common hell bus AO spy 369. Yes. When switching to non-DMA, we need to make sure DMA is off. Otherwise, the S2 will transmit at zeros instead of our data. I remember we had a bug about this. And where did the SPY LL stuff go? That is the question. LL setup link. Include sock. I guess I could. I'm so used to this not working. This box here. Oh, and it didn't work. Isn't that what it's called? TXDMA start. Oh, you know, that's the disable? Huh. Why isn't that working? Where else would it be? I know that there was stuff in HAL that they moved. SPY. Oh, here's a bunch of LL stuff. SPY LL. DMA FIFO reset. Oh, but you know, this is, I'm looking at master again. TX DMA. Ah, where is it? Here's what we can do. So my git status shows new commits, and I want to get back to figure out where it was. So what I can do is I can actually do a git submodule update, and that will reset ESP IDF. So now if I do the search, DMA disable. Right, so here it is. Oops. It's in components HAL include HAL SPY LL 301 S2 include. Where am I now? Like that looks like I'm in the exact right spot, but it must be gone. TXDMA. Bye, Mr. Who. I know you probably are gone already. Sorry. Seems like people just like the Q&A more. Wouldn't be a deep dive without this part. Let's see the history. So ESP32-S2 bring up. Separate the pointer for the TX and the RMX DMA. That sounds related. S2LL. Deep dive is Tim's favorite part. Okay, well, we're there. Okay, so DMA, TX DMA reset is now this out FIFO empty clear. So this is what we could do. Like, it's probably going to be the same thing. So if I switch to the ESP IDF, now that I've found it. Oop. You're holding your breath. Don't forget to breathe. Now what I can do is I can check out CircuitPython branch again, which will get me back to where I was. And move back, and then I can search for what I actually want it to do, which is out FIFO empty clear, which maybe is a bug in ESP32 or in 4.2 still. Unfortunately, we can also see if this out reset is done, which is this out under RST. It's like, is there any code? It doesn't look like it in the IDF that does the reset. Oh, there it is. I2SLL does it for the ESP32. But SPY-LL, so it might be a bug in SPY still, but not LC-conf. What is AG? AG is like grep, but modern. If you want to find it online, you search for the Silver Searcher. But basically, it uses all your cores to search files. Instead of just one process. Oh, that's a bummer. I hadn't thought about that. Don't I need to do the submodule sync stuff in the new ESP IDF? I cheated it because when I was on the CircuitPython branch, I moved back to the original, and I should have done it there, but I never did. And then I moved back. So it's okay now, I think. Clear out the FIFO empty error. So I think what I'm gonna do. Oh wait. Here's TXDMA disabled. That's what we're doing, right? So let's just see if this code is somewhere, but worst case, I'll just do it myself. Like, I am not ashamed, right? Like, no code in the IDF as this we currently have it has it. So I'm just gonna do this. I have no shame. SPY-LL TXDMA is this. So in our code, we just replace it. And so it's HAL hardware, HAL hardware. Okay. Like, we can patch that, it's fine. So let's make it again. What is the editing tool you're showing right now? I mean, the one with all the orange colors. This is my terminal, and I use... so I think the orange colors are coming from AG, which is my search program. And then the terminal, like the shell itself is called Fish. It's not Bash. Fish does these nice like autocompletes. So I like Fish a lot for that reason. Okay, so we still have this one error where this SPY-HAL cal clock config went away. So it's a similar approach. And like, this is probably something we should have done sooner. I have had some success just like they renamed things. So if I just look at like things that are similarly named, like maybe I can find the old version. You're welcome, Paul. Looks like there's a get clock config, but there's no set. And it's done in, it's declared in sock source hal spy hal, which is probably not the same on the new one. Components hal spy hal. I don't want the history though. So again, what I'm doing is like I'm trying to find what the equivalent is. This is such a pain, but this is because I'm switching pretty significantly between branches. Spy hal sock include hal, so it might be in here. Include hal. That looks good. Spy hal. And so what we're looking for is we're looking for the function we're calling that went away, because we're trying to figure out what it used to be, how it used to be done. So it's spy cal clock conf cal conf clock conf input parameters to clock conf. So here's cal clock. Oh, and there's a get clock conf. So I wonder if they just renamed it. Okay, so let's, there's this blame button. And what blame does is it splits a file up by different commits. So like the last time a line was changed, which is very handy. Phil doesn't like the name of it because like you shouldn't blame somebody. It's just like, I don't know what a better term for it is, but it's like history, like line by line history is really what it is. Okay, so there's this refactor hal context structures. So it's hal cal clock conf. So if we click here, let's see what they changed. Yep, Silver Searcher. New spy transaction. Let's look for clock conf. So interesting. The new version takes only 3 things, but the old version took a lot of stuff. And it was still called cal clock conf. What does our version take in is the question. Does ours take a bunch of stuff? Like, so let's find it. It's in spy 276. Yeah. I really wanted to get that out. Okay, so it does take 1, 2, 3, 4, 5, 6, 7 arguments. So I think what we're actually going to need to do is now look further back, which is, this is all good, like, Git stuff. Like, this is good, like, how do I figure out all this? Okay, so clock conf. So the last time this line was changed, it was only changing arguments. It wasn't changing the name. So this is like past where we were. And that was 3 months ago. So like, so this middle button here allows you to like go back to that point and look further back. So if we look at clock conf again, we can see now it's renaming that. And it's 5 months ago. And look at it just renamed it. That's perfect. So we could have totally tried this. We just need to change the get to cal or cal to get. Yeah, we need to change the cal back to get. Oh, Luz, were you saying get deets instead of get blame? That's a good idea. That's probably why the compiler was suggesting that to us too. All right, I think I'm gonna... Okay, so this is something I've seen. They moved a lot of header files from a sock directory to HAL directory, I think is the way that they did it. So if I go into microcontroller pin, I know you can only half see it, I'm sorry. I think if I really replace this HAL with a sock, it'll work. That looks promising. It's gonna fail to load because I don't think it's connected up. Let me see if Newegg's said that they're restocking stuff today. I want a new CPU. They haven't posted anything. Okay, so the IDF is unhappy, which is not good. I don't know what it's unhappy about, but maybe we can first. I want to just clean and see where I am. Then I might need to. Yeah. I thought. Which pip? Which pip? Oh, I'm not even activated. Okay, so let me do ESP32-IDF, and I exported already, I think. So let me just do the install thing again. Might have to redo that. Yep. I do export. There we go. So now I should be able to build, and just to be super, if you ever have build errors, the very first thing you should try is just clean and build again. It's just, sometimes the build scripts are just not quite perfect. Ooh, restock alert. No. If you're trying to get a GPU from Newegg, they're restocking basically all of them, but none of the CPUs. It's like, I could try to get it sooner, but at some point, like, all of these things that are really hard to buy right now will just get easier to buy as time goes on. Yeah, Bruce S says, I think any changes to the IDF need to clean. You're correct. Mark says, my GPU gave up on me on Tuesday. That was not fun. Yeah, I had a day in the last couple months where Linux 5.9 stopped working with the NVIDIA drivers. And so I went to Best Buy and bought an AMD card, because AMD actually has pretty good support. And they're way more competitive than they used to be. Okay. So now we have an issue where I added some targets that don't exist anymore. And this is definitely getting kind of far afield from the pin stuff, but at least we'll get on a stable version of the IDF, which I think is going to be a good thing. Like, rather than some random master commit in September. So I'm going to do, where is that long list? So this ESP ROM, this is all like not very good. It is something I thought, like, having a better build system is definitely something I've been thinking about. I don't think there's a good build system for bare metal stuff. I think I mentioned this. I bought the domain Bare Metal Ninja, which I'm proud of. So basically what will happen here is like it'll either just work, which would be kind of surprising, or we may have to add another library to depend on if there's symbols that we weren't able to find when linking. I don't know what the ESP-ROM thing changed to. Are there any final questions? I'm going to wrap up here shortly, even though I haven't been doing much of the IDF stuff or the actual sleep stuff. I needed to, like, we need to do this IDF switch. It's going to be kind of a bummer, and especially if we find bugs, but is that a take on Bare Metal Alchemist? No, it's not a take on Bare Metal Alchemist. The reason the ninja part comes from a separate low-level build system. Why did it? Why did it still? Oh, there it is. 2 places. That's fine. Full Metal Alchemist. No, there's this really cool thing called Ninja Build. And it can actually be used with CMake. Like, CMake can generate it. But Ninja's great. It does all of the, like, core build system stuff of, like, you change this file and these are all the things I have to change as a result, and run all these things in parallel and keep track of their output separately so they don't overlap. And yeah, Moto Timo says a ninja as in Meson. I think, yeah, like the Meson build system uses it as well. It's kind of like this insight of like there's 2 steps to build systems. One is figuring out everything that you need to build, and then the second step is actually just building it all. And so my idea with Bare Metal Ninja is to use Python to do that first step of like figure out everything you need to do, and then use Ninja to actually build it all. So you basically generate Ninja files. But no build system that I've seen manages this idea of like, Bruce S says, isn't Ninja used by the IDF build system? Yes, so the IDF uses CMake, and then the CMake generates Ninja. So like Ninja is very popular. The beef I have is like with the stuff that generates the Ninja stuff. Like nobody does like multiple boards of different things well. So okay, so now we don't have libhal or libxthal. Hal.a. Binary blobs. I wonder what... Let's look in... ESP IDF components extensa ESP32-S2 libhal.a. That's my guess, is that we actually want that. And no such file. I realize I'm... Okay. And because I'm changing the make file, I'm going to do clean again. Which is why I'm, like, doing other stuff, too. Microdev says, I've seen this before. I bet you have. Kevin says, hello from Seattle. I'm in Seattle, too. Tim says, let's talk about that build system. Oh, please. What am I looking for in a bare metal build system? I want one that handles multiple board definitions well. Meaning, I want to be able to build two boards concurrently and have the files that are the same with the same configuration built once. That's the challenge. Gareth says, will you be pinning to a fixed release or release plus bug fix branch? So yeah, I think what we'll do is we'll follow the 4.2 branch from the IDF. I don't know what commit the actual release is, but we'll follow the 4.2 release branch. And yeah, Tim, if you want to talk more about the build system, join the Discord, which you can do by going to adafru.it/discord. Are we all a band of bare metal brothers? We're certainly a band of bare metal people, but I would rather not assume that we're all men. I hope there are women watching too. Other folks. Thank you for your answers. Midnight here. Good night, Paul. Thanks for hanging out. Oh, Tim. Oh, perfect. Okay. Tim is Mototemo on Discord. Great. Yeah. I've started it. Why is it looking for... I wonder if I need to, like, delete it. Like, I just looks for it. Oh, here it is too. That's silly. So I think I have I'm gonna finish this and then I'm gonna get out of here. Bruce S says I ran into these when trying to try a new IDF version. Yeah, I mean, it's weird because I'm going back in time, but that release branch has fixes in it. So, like, it's back in time, but not back in time. Like, it should be back in time, but more stable. So I think it's the right call. If it really goes badly, we can always revert it. So maybe I should make sure it's in a different commit. But, yeah, so I started experimenting with the build system stuff. And I think where I'm getting at is I want it to be, I think I'm bare. Yeah, I have bare metal -ninja. And this is like, I just dumped the things that I was experimenting with. Part of it, I think, is what I'm thinking of is it's really, yeah, hopefully it doesn't break Tiny USB. I assume that Tiny USB works in 4.2. Yes, I did need to do a fresh install sh or fish. So I think one of the things I'm thinking about with the bare metal ninja stuff is that it's really a system. It's like a matrix. Like, it's defining a matrix of things of like, here's my source code and here's the dimensions that I want to build that source code configured for, right? So in CircuitPython land, that's, we build every board and we build every translation for every board. So that's like 2 dimensions. And then a third dimension you could think of is actually a tool chain, where that's 1 dimension. So you could think about, like, what if we had Clang versus GCC settings? So that's 3 dimensions that you could do. And then a 4th dimension you could do is like opt versus debug. I didn't see anybody get banned, so I don't know why Benny's having trouble chatting on YouTube. So I'm with this build system, I'm trying to think of, like, how could I make it actually a bit more generic in terms of, like, build matrixy things. And then I also want to be able to do, like, one thing that we do a lot in CircuitPython that I think is very successful is, like, conditionally compiling things based on path. So, like we have ports / like chip family, and like under those chip family things, Interesting. Bitbake. Yeah, generally I think things are too complicated, but I also have this, like, I'm very much a not invented here syndrome sort of person too. If you have links for how it defines that stuff, please send them my way. I may not use it, but at least I like to like get it in my brain so it can all like work together and stew. So yeah, that's kind of the place that I'm at still. Okay, so we only have one problem here. So let's just find this libhal thing. And this one's okay. We're looking for a different one, which I don't know where we're getting it. You know, the place we might be getting it is how port. Hal is such a common word. This expands out to that. Let's just delete that. Try it one last time, and then I have to get it. I want to get out of here. Ooh, it's written in Python. I'll overload your brain. No worries. If I was in a rush, I'm not in a rush. It is something that I've been thinking about of like, what projects do I want to use it in? I want to use it in, like, I want tiny USB. So I really want to make it easy to build projects based on tiny USB. Right? CircuitPython is one of them, but the tiny logic friend stuff that I want to do is one of them as well. Like, I want to make it very easy to build a C project on tiny USB that works across a lot of different boards. Tiny logic friend is this idea of like a firmware that works across a bunch of boards. So yeah, that's why I want to do this build system. I only used it when I was building Yocto for some board. Bitbake. I mean, I like the idea of a Python-based thing in front of it. Like, Zephyr does Python to CMake to Ninja. I think Ninja, maybe Make. CMake can generate make files as well. Meta Freertos. Oh boy, you're going to give me all this sort of reading to get in my brain. I hope you know what you're signing up for. Helping us doing stuff. Interesting. Variable expansion. Ugh. That makes me unhappy. That scares me. Like make-like stuff. I was also thinking about this. I do have also like this background in configuration languages. The on Twitch, it was offline for a moment. Did Twitch hiccup? I think it's all going. I really need to wrap it all up. Cannot open linker script. rom.api.ld. All right, well, this is where I'm at. I'm like trying to switch us back. I think if I just run it again, because it's a linker script thing. All right, let's wrap up. I gotta get out of here. As always, if you want to hang out with me and a bunch of other folks during the week, you can go to adafru.it/discord to get into the Adafruit Discord server, which is a chat channel. There's a CircuitPython channel there. We'd love to see you. That's where we do a lot of our development discussion for CircuitPython. So if you like watching the CircuitPython-y stuff here, that's a great place to follow along. If you want to support me, support Adafruit by going to adafruit.com and purchasing any of the cool, interesting things there that you see. Lots of it runs CircuitPython, so that's my bias. Oh, and it did try to connect to the serial, so it was ready to load. Time to cook some dinner for those of us on the West Coast. And as a reminder, next week is going to be on Thursday at 2 p.m. Pacific. So check that out. That'll be the last stream of the year. And I will post a thing, or you can ask me on Discord about what my plan in January is. I just haven't quite figured out. I'm kind of thinking maybe I'll get bored and want to do one over the holidays. So I might leave that open. Anyway, it's been a pleasure. Thank you all for hanging out and all the great questions. We had like an hour of questions, which was really good. So thanks again, and we will, I'll see you next week. Have a great one. And I just realized I was looking at the camera, but the camera wasn't looking at me. So, bye.